main point is that Abi designs ways to interact with Google's knowledge graph, a semantic network of over 570 million objects. She likes croissants, Tchaikovsky's violin concerto, and the periodic table of the elements. You made me have to say periodic table. And when not designing interfaces for the computable portions of human knowledge, Abi writes a webcomic at dearfuture.com. She's actually a very good artist and cartoonist as well, and rides her trusty 7-speed Schwinn, so she's not a hipster who rides a fixie, between the redwoods and beaches of Santa Cruz. So please, a big hand for Abi Jones.
Thank you. The conditions in the last days of the Winter Olympics were horrible. Throughout the day, the temperature got warmer and warmer, turning every ski run into slush and slowing down many later skiers, potentially keeping them from winning gold medals. This is a problem for Danelle Umstead, an American skier who was just 90 seconds away from the podium on her last day of potentially her last Olympics. As Danelle crouched at the gate, a voice rang in her head. And as she moved forward and down the steep slope that would propel her to 60 miles an hour, the voice got louder. It told her, lean left, sit forward in your skis. It's bumpy ahead. At each moment that Danelle felt she could go faster, she willed to that voice, go, go, go. And in return, it gave her instructions on how to crouch and turn. And eventually, she made it to the podium. There are a lot of differences between anyone here and Danelle. We aren't competitive skiers. We will probably never move with the grace and athleticism and speed that Danelle moves with, and especially not down an icy slope. But what we do have in common with Danelle is that we need a coach. Danelle doesn't ski alone. She's blind. She skis with the aid of her husband, who is just 10 to 15 feet ahead of her. And they communicate via Bluetooth, headsets between their helmets. Danelle gets instructions on which way to turn and how to move in her skis and where to sit along her skis. And we can learn something really important from her. That if we are going to offer assistance to our users, that we need to make sure that assistance is simple, like the very short phrases that pass between Danelle and her husband, that it is easy to understand, that it's just in time. Danelle doesn't get instructions for 6 skates ahead. He tells her what she's going to experience in the next few seconds. And when she feels like she can go faster, she lets him know, and he, in turn, helps her speed up. There's an adaptation there. So as we consider help today, I want you to think about these things. Whether or not the experiences we design, and especially ones that are based on gestures and voice control, follow these principles. So we should be offering help that is simple, that comes just in time, right as you need it, and that adapts to user needs. I'm going to show you a lot of different UIs, and I'm actually going to ask you to move around a bit today. So I know how exhausting it can be to be at BayCHI at the very end of the day, and the seats are semi-comfortable, and your coffee might be wearing off. So we'll move around a little bit. It's not going to be pure lecture today. First, I want to start by taking you through some different gestural UIs. So think about what makes it so difficult to use a gesture-based UI. Why is it hard? Any ideas? It's unintuitive. There's no frame, no reference. Are there often affordances with what gestures you can use? There's no visible way to tell what selections you can make. So think about something like The Verge, so this is today, and what they do as designers is they say, okay, this is a touch interface, this is on a phone. How do we show somebody that you can swipe horizontally on this interface? There's this little peak right here. So that's how you design an affordance on a swipe interface. And that's for one of the simplest gestures. The swipe is a gesture that showed up on the very first iPhone commercial. So even with a swipe, we need to show people, hey, it's possible to move this. And because each of these panels is less than the full width of the phone, you know that you can keep going, and it shows you that you can get back as well. So when you're just dealing with the very simplest of gestures, it's nice because you can do things like have these visible affordances. So when you're just thinking about tapping, we show buttons, areas where you can interact with. Swiping, we can show these peaks, we can show additional chunks of content. With pinching and zooming, there's this idea of seeing something too small and the natural human inclination to want to get closer to it. But what do we do when gestures become more difficult? Now, there's a lot of promise in gestural interfaces like these, in the science fiction gestural interface. And this is an expert level one. There are companies that are trying to make it a reality, so you think about something like Leap Motion, which is a really amazingly difficult way to browse Pinterest. So now I'm going to make you practice some Leap Motion elements with me. So here's actual video of me attempting to use Leap Motion. So you can see different tutorials, and it shows you how to move your hand around. To rotate the globe, you move your hand up and down, which means if you want to rotate the globe, you have to move your hand like this. And I'll show you from the side. You actually have to move your hand out and back because the Leap Motion has an area where the sensor can see you. And if you're inside of that area and you move your hand back down too fast, then the globe spins the other way. And it looks like the most horrible earthquake in the world is happening, literally, because of the way our bodies are constructed. And that it's really difficult to, that's actually my favorite gesture, and down. And the New York Times folks made that one, it's the smoothest. What's difficult about using the Leap Motion is that every single application you use makes you go through something like this to use it. Do you want to dissect a tarantula? You're going to get a tutorial like this. Do you want to play guitar with your fingers? You're going to get a tutorial like this. Every single system in Leap Motion has different gestures implemented and a separate tutorial for each one. And think about the last time that you opened a brand new application and you saw a wall of words with a close button. Did you read everything that was happening there? Do you read all of the text that you see in front of you anytime a window pops up? And those windows explain how to use things. But we're so busy and we so want to use the thing that we've just decided to download that we don't have time to read instructions. And this is the paradox of the motivated user. There's a team at the University of Texas, El Paso, who figured out, and this is specifically in relation to desktop applications, that when people could gain the most from learning how to use an application, they were the least likely to actually read the instructions and learn how to use it. So how we usually think of learning is that you'll learn a lot about something at the very beginning, and then as time goes on, you have to learn less and less about it. Whereas in reality, when you're learning how to use a new program, you need to learn a lot at the beginning, but then as time goes on and you get better at using that application or that program, you actually need to learn more and learn different things about it. So think about the first day you ever opened up a spreadsheet application. Did you use every feature of that application on the very first day? No, but as time goes on, you increase your expertise, and then you need to unlock new information in that application. Game designers already know how this works, but as we think about business software or even just any 99-cent app you download from the App Store, what happens is every time you open it up, or the first time you open it up, you get all of the information at once. And that doesn't help our users, does it? It's not giving them instructions or help that are simple, it's not giving you something that's just in time, and it's not adapting to your needs. So ideally, you'll know when your users are coming in to use something, and you'll be able to give them those help pieces at every step of the way. So now I'm going to make you watch some video of me attempting to use the Weather Channel application. And if you notice on the right-hand side over here, there's this box. Is that your right? Yeah, all right. On the right-hand side, there's a box, and it's a cheat sheet. Now, this cheat sheet, it seems like it would be a lot of help, right? It tells me everything I need to do, tilt up and tilt down, how to pan left, pan right, how to scroll, zooming in and zooming out. The problem is that cheat sheets don't actually help your users understand how to use a system. So if you offer a cheat sheet like this in your application all of the time, your users' brains are going to say, I never have to remember that ever. And there's actually really interesting research out of Saskatchewan where the team did was that they created a gesture-based system, and they had people draw different kinds of lines. And what they found was that the people who had a cheat sheet showing them what shape of line to make, when they took away the cheat sheet, nobody could remember how to make that shape of line. With the team that had the shape of line that they could trace, eventually the shape of line disappeared and people were pretty good at tracing it. But for the people who had a traceable line that disappeared over time and got smaller, making your brain fill in and realize this isn't going to always be here, those people did the best at recreating that line later on in a gesture-based system. It was that understanding that the support mechanism isn't always going to be there, and that I actually need to learn how this thing works. Are you guys familiar with the Kinect? When it first came out, it could map about 48 points in the human body. It could tell the difference between you picking up a beer to drink it and your dog's tail wagging. And it's actually become even better over time. What is interesting about the Kinect is that when it first launched, it had a very specific action for selecting an object. So are you familiar with the action it has? The first one? Well, let's all practice it together. So how you select something when the Kinect first came out is you hold up your hand and you just let your hand sit there until it sees your hand and the thing is chosen. And what researchers at Microsoft found was that people weren't sure the Kinect could see them, and so they start waving their hand around like, hey, what's going on? Which is the exact opposite of what they wanted. It's like, no, we have to recognize your entire hand. Stop doing that. Because it's actually really awkward to hold your hand out like that. And when in real life, I'm not talking about celebrating a home run, do you hold your hand out like this? Do you ever hold your hand out like this in non-high five situations? We don't, right? Stop. Okay. Oh, Diana Ross, she holds her hand out like this. Hammer time. So there are some limited situations where you might hold your hand out like that, but it's not actually a very sensible gesture for human beings. So what happened with the Kinect team was that they redefined the way that you could select something. And what happened was that different application developers like Just Dance, they're just like, we're going to make a different gesture because this whole holding your hand up thing forever is not working out for us. So this new gesture is one where, let's see if it plays if I press this. Yeah. Is where you actually press the thing that you want. Now, are there points in the day where you press something? You know, an elevator button, honking a horn if somebody slams on their brakes or doesn't go. There are a lot more times when we press something than when we just hold our hand out in the air. And the nice thing about pressing something as a gesture is that people who do it can actually get faster and more accurate at it. And so it's something that adapts to user needs. So it's simple, and this tutorial comes up, and it just gives you a few things. It just says, all right, all you have to do is choose Skype, which is a product tie-in, but you probably, since you got to Kinect, want to play Xbox games. And it shows you really quickly, here's how you select something. So it's one of the better tutorials out there. There are other ways that we can teach people how to use different gestures. So I've covered cheat sheets and tutorials. One of my favorite, though, is the Moto X, and its gesture for opening up a camera. So This is an advertisement, and advertisements are actually really great ways to teach gestures. Anyone who bought an iPhone already knew exactly how to use it before it came out, because they'd seen a commercial showing them all of the gestures you could perform on the iPhone. And each gesture is repeated several times during the commercial. So in this case, you have the Moto X, and she twists it. The camera pops up, and she takes a photo by tapping on the screen. Now, for me, I like the Moto X because I don't even have to look at it. I can just pull it out of my pocket, twist it down low, and be ready to take a photo. And because I can tap anywhere on the screen to take a photo, I don't have to worry about mishitting a camera. So even the camera that you can pull up from the bottom on the iPhone is a little too difficult for me. So a few months ago, I woke up really, really early. I'm talking 4:30 in the morning. And because it was summertime, I was able to walk around Santa Cruz and take photographs of one of my favorite things, just sidewalk stamps. Sidewalk stamps are the stamps that contractors put in the sidewalk after they've built a section of the sidewalk. Ones I've seen lately have URLs on them, which is always pretty fun. Some have phone numbers. And it's pretty neat because I can actually then look up these people and see whole family histories for Santa Cruz, which is where I live. So one morning after waking up really early, walking all over Santa Cruz, taking photographs of these sidewalk stamps, I decided I would stop to get an ice cream. It was only 10 o'clock in the morning at that point, so I figured a coffee ice cream would make a lot of sense. So I got my coffee ice cream, and I headed down to the beach. And the beach was full of beach volleyball players, and the sun was just coming up. And it was this sort of perfect, gorgeous California day that makes you think, I should put this on Facebook. So I got out my phone, and I lined it up with the beach and my ice cream cone, and I tried to take a photograph. Except the ice cream cone wasn't in focus, or then the volleyball players wouldn't be in focus. So I took picture after picture after picture because I couldn't figure out how focus worked on my gesture-based phone. And it turns out that how it works on the Moto X is that you slide out the focus settings from one side, and the gallery is on the other side. And I never had a problem using the gallery, but I'd completely forgotten about the focus part. And it was something where the designers of this application could have built in tools that helped the program peek out that from the side if I kept pressing an out-of-focus picture over and over and over again. Or they could have noticed that I was trying essentially the same actions that would have focused an iPhone, but didn't. And so because I'm the kind of crazy person who takes screenshots of interactions, I was able to go back into my photo history and figure out how to use focus on the Moto X. But most people aren't going to be able to go back to their photo history and see how to use an application. Do you think your users are taking screenshots of your instructional materials? No, they're not crazy like me. Eventually I got my photo, and I posted it on Facebook. But it took a lot of time, and it felt really embarrassing holding up a rapidly melting ice cream cone with a phone. You have to have a lot of either self-confidence or complete ignorance to be doing that. So the assistance that I got from the phone, it wasn't helping me just in time. My phone could have seen that I was taking bad photo after bad photo, but it didn't offer me any sort of assistance. It didn't give me anything that was simple to understand. And if I go back, some crazy stuff going on right there. And this right here, that's going to happen the first time you load focus, but then when will you ever see it again? So there are ways that we can improve gesture-based systems like this. And it comes back to that fact that in a lot of these systems, we're hiding any possible affordances that could have been there. And so it's something you have to ask your users, have you hidden every affordance? And specifically, if you've hidden affordances that are for very well-known gestures, it might be easy to get away with, especially if there's a physical object to bring it back to. So you don't necessarily have to put affordances on a photograph because the photograph itself becomes the visible element. But in this case, if I'm trying to improve focus and my focus icon doesn't work at all, it makes it a lot difficult for me as a user. So an easy way to think about it is the 5-second rule. And it's not about food. Instead, it's about offering help 5 seconds before your user actually needs it. And it means showing a lot of restraint. So when the Evernote team decided to add drawing to the Android application, and the ability to draw in your notes, the very first thing they did was add instructions to every single part of the drawing application, including telling you how to choose colors, how to choose text, how to draw a box. And after testing it, they realized that people already had a pretty good idea that if you tapped on a color, you might get to choose other colors. That thing for choosing colors looked like a button. That thing for choosing text looked like text selection. What was really difficult for users was the idea of how to scroll. If you're on a drawing canvas, it's actually very difficult to scroll because you end up, as you swipe up, drawing on it. And so they added one piece of instructions for a gesture-based system, and that was that you needed to use a 2-finger scroll in order to scroll on the Android application. Now, that's not a common activity on Android devices, but if you look at the entire spectrum of gesture-based devices, including the wealth of iOS devices out there, and MacBooks, then you actually have a lot of different devices that have 2-finger scroll. And so you can connect your application back to those devices and back to previous knowledge that your users have. They really learned that they could, as long as they took out as much information as possible, they could highlight one thing and then show it right before you needed to use it, following that 5-second rule. Another application that does this is CamMe. So it has this contextual system for showing you gestures where it's an app for taking selfies. I should explain. CamMe is an app for taking selfies. It's very useful if you are trying on outfits and you want to send them to your friends. Because just think about when you take a selfie. So please take a selfie with me. Hold your hand up like you're taking a selfie. Exactly. So that's the problem, right? Can you get an entire outfit in a selfie? No, you can't. So the beauty of CamMe is that you can set up your phone at a distance and you can get away from it. And then all you do is you hold up your hand, and you can see here it says raise your hand, that crazy raise your hand thing. But then it just tells you, as soon as it sees that your hand is raised, it tells you to close your fingers, and then it gives you a 3, 2, 1 countdown, and it takes a photo of you. So you can prop it up in a dressing room, you can put it on a shelf, and you get the countdown. And it doesn't tell you, okay, here's what's going to happen. You're going to raise your hand, then you're going to close your fingers, then there's going to be a countdown, then we're going to take a picture. No, it's one step at a time. So that's all that your user needs. And this is a really focused application, so they understand the outcome is going to be a photograph. Do you have a question, or? No. Okay, so the question is, do they do that for every time you want to take a picture? And they don't. So as time goes on, they don't keep telling you, please raise your hand, close your fingers. That actually only appears at the beginning. And then as time goes on, they just show you the icon. Because the icon is the feedback for your gesture. So it both shows you what you need to do, and then it shows you that it's seen what you've done by showing you the next icon. All right. So as we think about gesture-based systems, one area where it's really easy to get confused as a user and as a designer is the application and software layers of it. So how many of you have iPads? iPads here? All right. Do you ever use any sort of application or website where you scroll a lot on it? Okay. Have you ever caught that drawer at the bottom of the iPad? It's like, oh, you want some Wi-Fi? You want a flashlight? All right. So that's a conflict between a couple of different layers on a gesture-based system. And so one way to consider thinking about the interaction layers for gesture and voice-based systems is that first you have a device. Now, right now this is not a very exciting layer, but there's a lot of interesting work being done on actually having gestures on devices. So it's not out in public yet, but think about the digital crown on the Apple Watch and how you're actually going to interact with the device itself, not with the software inside of the device necessarily, or the screen. There's a lot of cool research at BayCHI this year about how to interact with areas around a watch or on a phone. If it has metallic edging around it, that instead of thinking about getting out your phone, so get out your phone right now. All right, turn your volume up on your phone. Did you look at your phone when you did that? Do you consider it easy to turn up the volume? Is it easy to tell the difference between the volume up and down buttons? Oh, you're not with a case on. So think about a gesture-based phone where you could just run your fingers up one side of the phone to turn the volume up. And that could be based on how many fingers you're using or how rapidly you do that. And so right now it might seem crazy to consider the gestures that we might have at a hardware or device level, but it's not something that you should ignore. Eventually, there will be gestures that happen on our devices themselves, not just us interacting with the software, but us interacting with the device. It can include being able to tap a specific number of taps or pattern of taps to unlock a device. So these are one type of gesture to think about, a device or layer. And then the next is the operating system. The operating system is where we run into that issue of pulling up the drawer on the iPad when all you want to do is scroll. So often we have interruptions between the operating system and the application that you're using. And this is where you're going to have a lot of conflicts when you're working on gesture or voice-based objects, is that when you're thinking about how to implement a voice UI, you have to make sure that none of the gate words, and gate words are those words where that will trigger the voice UI, that none of those are going to be the same as the gate words that might be used by the operating system itself. So one way some device and software manufacturers will get around that is by only allowing their specific applications to use voice. But another way that you can look at it is by just thinking about whether, I shouldn't say just, but thinking about what strings are specific to your application. So do you guys understand what gate words are? Do you have a device that has a gate word? All right, so the gate word on my device, okay, Google. What's the gate word on your device? Nobody has an iOS device. You don't talk to your phone, do you? I'll tell it. Hey, Siri. Yeah, Siri is so lonely suddenly, you guys. Oh my gosh. I'll tell you in a minute why you don't talk to Siri anymore, though. The second place we get a conflict is between the content and the application itself. And this is an issue that shows up on Google Now, and the Google Now team knows about it. But it's something where when you swipe across to bring Google Now onto your phone screen, if you swipe a little too hard, you end up deleting one of the cards in Google Now. And it's just like, wait a minute, that was my movie times. And then you have to press undo and bring it back. And it's a known issue. There are only so many places your swipes can come from. And as long as we're restricted to just gesturing on device, which is the reality right now, but won't always be the reality, we're going to run into those restrictions. There are only so many axes that we can interact with the device on. And the last one is the subcontent level. So thinking about the times when you've decided to open a menu and you want to select something in a menu, but you accidentally select the content underneath the menu. It happens to the best of us. It's okay. These are the places where conflicts can occur. And so what's really important to think about is if you're implementing a gesture-based system or a voice-based system, to know what the gestures are at each of these different levels. And especially at the operating system level, one set of gestures people forget to look at. And so I've talked to you about, you have the drawer from the bottom on iOS where it has those utilities. You can pull down from the top to get your notifications. And I'm sure you've experienced that where you've accidentally swiped and gotten your notifications by accident there. But one place people don't think of very often are accessibility issues. And so one good place to explore is to look at accessibility tools on your device and your operating system and see where gestures you are considering implementing might be in conflict with accessibility features. And so it's really important to test your products with those accessibility features enabled to make sure that you don't have any conflicts there. So how do you figure out what gestures to use in an application? One thing you can do is you can create a guessability study. So a team at Google developed a study where they handed people either an inanimate object, like a block of wood, or they didn't give them anything at all. And they asked them to perform different gestures. Can you show us answering a phone call? How do you delete something? how do you send an email? And they had people perform these gestures on non-working devices with no screens enabled, just imagination. And they actually found pretty significant agreement between some of these gestures, so including making a phone call, being simply lifting a phone to your ear. And it's something that, I don't know if it's taking you by surprise, but I will often press a phone number, and then because my phone doesn't automatically start calling, I just lift the phone to my ear, and then nothing happens, and then I look at it, and the phone number is just sitting there because I haven't pressed call. Eventually, that will happen. Eventually, a phone number will appear on your screen, and the moment that you lift up the phone this way, it'll call. So what gesture would I have if instead of doing a phone call, I wanted to do a video call? What would that look like? Yeah, I would bring it up to my face. And so if you're curious about the kinds of device gestures that people would do to get something done on your application, you can, without any actual prototype of your application, you don't have to figure out how to code the gesture in advance, simply ask people to show you what they would do if they wanted to do one of these actions. To take it a step further, though, we have on-body gestures. So this is a completely different research team, and what they did was they actually asked people to make different gestures using their arms. And so they limited it to just the arm. And they found that for gestures that involve any sort of skin manipulation, so any gesture where a pinch made sense or to push skin, the back of the forearm and the back of the hand was really useful. For gestures where you were doing any sort of addition or calculations, then the palm was really useful. And that nobody wanted to do gestures on their elbows. I think the feedback was, I don't want to touch my own elbow or other people's. So as watches become more popular, it's going to be important to think about not just gestures with the interface, and not just gestures with the device itself and the watch, but gestures on your arm. Because just think about how small a watch face is and how difficult it could be to scroll on one. But how much bigger is the back of your hand? And in the study, they found that people were generally okay with touching the back of their own hands. And what was really interesting was that when people were going to select something from a list, so let's say they got a list of search results, and they wanted to select the third item, they would touch their finger. And so there are all these small, interesting things that will pop out in the next few years, or in the next 25 years, that you'll see come to the front in gestural interfaces. And we'll have to think about how to teach people those gestures in a way that's not weird or makes people feel like they shouldn't be touching their own elbows. One caveat to this study is that it was performed during the summer, so people were generally wearing short-sleeve clothing, though the preferred area for gestures was from the forearm to the wrist. This could be more difficult in Minnesota. So it's something to think about. We're really biased here in California. If you're building product and it's during the summertime and you live here, you might end up building something that completely doesn't work on the North Pole. If it's not a concern for you, that's okay too. So I want you to take a minute to just turn to the person next to you and tell them how long it took you to get here. Wherever you came from. All right. Do you have a pretty good idea of how long it took you? Bill, how long did it take you to get here? Fred, do you know? Yeah. 10 minutes from the restaurant? Okay. All right. Now imagine you're holding your phone. So you don't have to get out your phone itself. You can hold the fake phone. Ask your phone how long it'll take you to drive to San Francisco. Ask your phone, think of a restaurant that you like, ask your phone for directions to that restaurant. Did you use the same tone of voice to talk to your phone that you did to talk to the person next to you? No, you talk to the phone sort of like a bad dog, right? So you enunciate clearly, like, navigate to this direction. So I can always tell when my colleagues are testing voice search because you can tell from across a building, it's like, oh, they're talking to a phone. Because it's so awkward and uncomfortable and unnatural, right? It's really weird. And that's because the current state of technology in voice interaction is that it's essentially like a phone tree. It's not really anything better than your credit card company has. And so we treat it like we're talking to our credit card company, or we're talking to the DMV or the bank. And none of those people make you feel really excited to be on the phone with them. So it makes voice search, or any voice interaction, really difficult and uncomfortable. It's not very fun. So how can we fix it? Now, earlier I asked you guys about the gate word for iOS devices, and nobody had any idea. Do you guys use Siri at all? Yeah? People are like, oh, maybe. I think it's on my phone. I saw a commercial about it one time, and I added a calendar appointment. If you look at the three major voice-based ways to interact with the phone, so think about Cortana, Google Now, and Siri, what are they doing right here? Oh, on the next slide. Is it playing? All right, so what are they doing? Oh, hey, Ben, and this is a beta version of Cortana, so it's a different color now. The first thing it says is, it recognizes you. It says, hey, I see you there. And then it tells you something you can do with Cortana. It's like, you can have a reminder to water the plants when you get home. With Google Now, it recognizes you're there, and then it tells you, say help me if you want to know what you can do with Google Now. And then with Siri, it gives you the same thing. It's like, you can ask for help, or if you don't say anything, we're just going to show you a list of things that you can ask. The trouble with this is that it's not just in time. I don't necessarily need to water my plants when I get home. Like, thank you for the reminder, Cortana, but that wasn't really helpful to me. It doesn't really adapt to what I need. So thinking about Google Now, I could say help me, and I could get a list of things, but have you ever gotten, and I'm not talking about BuzzFeed, but have you ever seen a list and been like, yeah, it's the best list ever? And sometimes I see lists and it's like, yes, those are 10 signs I live in Northern California. But usually when it's like, do you want a list of something? It's like, no, I don't want a list. Because it's giving you something to do. It's giving you a job or a task. And if I pull up one of those lists, or I look at the list with Siri, like, well, how many of those things do I really need right now? Do I, at this moment, or 5 seconds from now, care how long greyhounds live for? Do I care how long anything lives for right now? It's like, no, maybe if I'm in a bar making bets with people about how long things live, then I care. But this isn't really just in time. And it's more than not just in time, it's actually really overwhelming. So when you think about voice interfaces, there's this serious aspect of novelty when you first start out. It's like, oh my gosh, it's so amazing. I can make calendar appointments. I can ask when my next meeting is. I can tell it to call somebody. But do you really use it that much? At the very beginning, you might use it a lot. But then as time goes on, what happens is we actually forget what these interfaces can do. Do any of you feel like you actually know every single thing that your phone does? No. Are there any phone engineers here? Okay. So I don't know every single thing that my phone does. And I probably don't need to know everything it does, but am I ever going to sit down at some point and read a manual or read through a list? No, instead, my phone needs to understand the context that I'm in and respond to that context. So if I keep asking questions of my phone that seem like I'm in a bar making horrible bets, then it could say, well, do you want to know how long greyhounds live? It's that adaptability that's really important, because the novelty of a voice-based device is going to wear off really quickly. And instead, if you're designing one, you're going to need to know what your users really need out of it and what their day-to-day needs are for that voice-based system. And then you're going to have to remind them over time. So Google just started an ad campaign. It was like, hey, we have all these cool features. We probably should tell people they exist. So you can ask different questions. Okay, Google, what's the Cat's Deli slogan? How many holes does a bowling ball have? And they're context specific. The bowling ball question is on a bowling ball. The Cat's Deli question is at Cat's Deli. Now, do you think Google will be able to do this outside of a single city? In every town in America? No, I don't think so. No company can. But you can use sensors on your device to get an understanding of where people are and what their needs are. You can use the information from them to figure out their contexts and make sure that the actions they're performing are actually relevant to what they're doing. So this is an example where this advertising, even if it's not the exact task you want to perform, is pretty simple, and it's given just at the right time. The best place to use a device is when you have to be hands-free. So it's when you're cooking, when you're changing a diaper, when you are driving, when you are trying to put together IKEA furniture. Those are the times when it's really helpful to have a device that you can just talk to. But the problem is that we don't really have that opportunity right now. So even with conversational voice search for Google, you still have to say, here's the first part of my question, and then you say, okay, Google, and then ask the next part of the question. So if I want to know how tall the Empire State Building is, I can say, okay, Google, how tall is the Empire State Building? I turned my phone off so I wouldn't constantly trigger it during this talk. Okay, Google, how tall is the Empire State Building? And then it tells you, and then you either have to stop what you're doing and press a microphone button, or you have to say again, okay, Google, who built it? And it starts to feel a little bit ridiculous after a while, because that's not how we talk to each other. And if you truly want to be hands-free, and you want to really use a voice system for what it's good at, you shouldn't have to press that microphone button again either. So neither of those things really work out very well. But I think this is really a short-term problem. And so when you're thinking about voice-based systems, at this very moment, yeah, you're going to have to deal with the really crappy fact that you can't continuously talk to a voice-based system. But when you're thinking a few years down the road, it will be possible to do that. I think what's really interesting about things like this, where you have to switch modes, so thinking about every time you want to ask a new question, you have to press the microphone button again, is that we actually have very real heuristics out there about switching modes and how much time it wastes for people. People might not realize this. Larry Page has actually taken HCI classes when he was a computer science student. I think the thing he remembers most from them is that his instructors drilled into him, like, switching between a mouse and a keyboard wastes a lot of time for people, and we know how many milliseconds it wastes for people. So we should be really cognizant of how much of a pain in the butt it is to switch between a mouse and a keyboard. The same thing happens in voice and gesture-based devices, is that when you're switching back and forth between voice and gesture, or between the keyboard and voice, is that you're wasting a lot of time for your users. And so it's something to just think about when you're creating a UI. So consider the application you make. Is it simple? Does it appear just in time? Does it adapt to user needs? I think there's a lot of room for improvement in a lot of different applications, in particular in how we handle errors on voice-based systems. This is me trying to chat with my husband and realizing that on Google Glass you can't delete anything. It just sends into chat everything you say without you realizing it's going to happen. And him making fun of me for not realizing that. And so one of the areas that we really have to be careful of in a voice-based system is how we help people understand what they can do. So on Google Glass, you constantly get these suggestions, like take a picture, record a video, get directions, send a message. And they pop up, and you just get a few at a time. You can scroll for more. But that we still don't have really good ways of handling errors for people either. So there's a lot of improvement to get there. There's no delete on Google Glass, just like there's no delete on the internet. I fear that I've only shown you a couple of really great adaptive interfaces. So one was how the Connect team redesigned how you selected items based on a different gesture, pressing rather than holding something up, rather than holding up a hand. And then another one was at the CAM-ME, where it showed you fewer and fewer instructions over time. And sure, I told you about the research study where people drew lines, but do you make applications where people draw lines over and over again, or no? So one of the coolest things out there is the Winston Show. And it's a game, well, it's an application for kids. It's not just a game, it's a storytelling tool, actually. And so the Winston Show lets your kid talk to it. And it's conversational. And what the people who make this application found was that they had one question, and specifically in this round, and actually they update the application constantly, so there are new stories for your kid and new things to experience. And what they found was that when they asked kids what their favorite kind of ball was, they didn't get the answer they were expecting. So they had already in the system, they had answers for if kids said soccer ball, kids said basketball, kids said football, but they got kids saying gumball. It's like, what's your favorite kind of ball? Gumball. And they didn't have an answer for that. And so their system was like, oh, it can't keep going. It can't keep telling the story because they hadn't thought about gumball. And so really quickly, it's like, all right, we got to have an answer for gumball as well. And they actually do a lot of user testing, and they get feedback, and they can see how people are responding to different prompts throughout the storytelling to make sure that they're offering the right information in return. And so when you think about something like the Winston Show, it makes you realize that the Wizard of Oz kind of setup for voice interfaces is actually really, really important. Just think about how awkward and weird it is to talk to your phone. It's not like talking to a person. But imagine prototyping that kind of voice experience. It's not very fun or engaging. It's robotic. Instead, imagine prototyping a voice experience where there's an actual human on the other end pretending to be a machine. Because that's actually going to be the most effective way to create something and to really get responses from your users and from your testers that are going to be useful over time. So I don't have anything grand to say after that, but I do have a lot of resources for you. I have a whole list here, and I also have a section called Random Cool Stuff that I can talk to you about. So do you guys want to hear about random cool stuff? Okay, cool. All right, I have a few random cool things to tell you about. This is stuff I came across when I was doing a lot of research on voice and gestures. So number one, mouse traces. So this team, who was all across the world, got together and decided to make a program where they set up two adults who couldn't see each other on separate computers, but each one could see the other person's cursor. And they gave them instructions, and they said, okay, you're going to chase the other person, and they tell the other person, you're being chased. And they would move their mouse cursor, and I can play this one for you guys over and over again. They would move the mouse cursor in these different directions, and they told them about chasing. They said, oh, you're going to court each other. You're going to fight. You're going to guard this other cursor. You are being guarded. And what they found was there's different types of traces over time. So the vertical one is time. And then you can see how the mice interact with each other. So we have chasing, it looks all crazy, but courting is sort of like this lazy spinning dance. And so what they did was they took the actual mouse interactions on a screen, so you could see two cursors at once, and they showed these interactions to children and adults in Germany and children and adults in Brazil who were part of a hunting and agricultural society. And they found pretty significant agreement on what these cursors were doing. amongst children and adults in Brazil and in Germany. And not so much on guarding. That wasn't one that people could easily get. But it was really easy for people to watch two mice. And so go back and show this one. And what are they doing? They're chasing each other, right? What it comes back to is that human beings are really, really great at identifying motion and what motion means and what's behind it. And it's a survival skill. So we're also good at identifying without even seeing a human body, but just the motion of a body. From a very young age, if that person is a man or a woman, how old they are, and even in some cases, what their sexual orientation is. And the reason we can identify those things is because we need to know if the person coming towards us is a threat or not. Are they going to help us? We have an amazing ability innate to ourselves, and we've been trained over time as well, to recognize gestures that are dangerous or threatening. Or, in the case of the courting mice, ones that mean love. So that's my first cool thing to tell you guys about. The next one is stress. How is the Apple Watch going to measure stress? Yes? Galvanic skin response. So can you tell us, okay, so I asked how the Apple Watch would measure stress, and we got the response, galvanic skin response. For people who aren't familiar with that, should I explain it, or? All right, so. Yeah, we can do that. We can start talking more to each other. So it's basically measuring to see whether or not you sweat, and if there is increased response between, well, basically measuring, like, is there moisture on your skin, and can we connect? Other mics. So that's a way that an Apple Watch can detect stress, is essentially, do you have increased moisture on your skin? Is that correct? All right. But you don't actually need sensors to detect stress. You don't need a special watch to detect stress. There's a team out of UC Berkeley who presented at CHI, and what they found is that with about 100 to 200 mouse gestures, where you told them at the time, here's how I feel, they could then take another set in the future of 10 to 20 of your mouse movements and tell if you were stressed or not with 70% probability. Not from a sensor, not from measuring the moisture on your skin or your heartbeat, not from pulse oximetry, but instead just by the tension that's created in stressed muscles and how much choppier your mouse movements become and how much less smooth they are. Which I think opens up an entire interesting field to think about how gestures are interpreted by our devices. It's a little frightening at times to think about, I was like, oh my gosh, my phone is going to know not just my email, but also how I'm feeling based on whether or not I swipe left or swipe right. But it also could be really amazing and interesting for monitoring the health of a patient who has tremors, just by being able to track their gestures. And the last one is consumed endurance. And this is a team who figured out an exact metric for gorilla arm. Are you familiar with gorilla arm? It's the idea that if we use these screens that are in front of us all the time, we're going to get giant muscles, like tennis players. So what they did was they went through and they actually created mechanical arms and figured out the exact amounts of stress. So the highest stress points, the most difficult points in your body are basically from your elbow to your shoulder. Those parts feel the most stress on your arm. Your wrist actually feels less stress when you're using a gestural interface than the rest of your arm does. So what they found was that it makes a lot of sense to put menus on the bottom, because that way you don't have to lift your whole arm up. You can just motion down here. This is for gestural interfaces within the air gestures. They also found that it's really important to not have a prescribed small area for writing a gesture in, but instead let people write gestures down low if they need to, or off to the side, and whatever is most comfortable for them. And then, I have another one, mode switching. And this is from 2003 in Microsoft, but it's really important. they gave people a task and said, you need to copy something from my Internet Explorer into this form. And we'll give you one of 3 ways to copy it. You can either use the mouse. You can go up to the edit menu, highlight the thing, go to edit, copy, paste it into there. You can use a chord, which is keyboard shortcut, or you can use a dedicated key on a keyboard. It's off to the left of the keyboard. And see, this works. So it's this thing right here. Shows up right there. Actual cut, copy, and paste buttons on a Microsoft keyboard. This was admittedly by the Microsoft keyboard team. So it's important to know where your research is coming from. But what's the fastest? The chord? So there was one place where the chord was just as fast as the dedicated key. They found that in copy-paste exercises, that the dedicated key was actually 25 to 33% faster at different tasks versus chord keys. Significantly faster during the mouse. The mouse really, you get slowed down between selecting and then going up to that menu and choosing cut or copy. But that on the chord keys, once you put your fingers on the chord keys to copy, they're already there and ready to go for paste. So they only saw a 4% difference in time. Yes? Yeah. Oh, so the question is whether or not this study accounted for people who are already very good at touch typing and knew where the keys were. So the people who were in this study were regular computer users. I can't say whether or not they knew the keyboard shortcuts, but they were pulled from a pretty wide group. And while this special Microsoft keyboard is available in stores, it was also not necessarily very widely used. So I think you get a little bit of a trade-off there. Definitely recommend reading it. And then I'll put the resources page back up for you guys if you're interested in learning more about gestural and voice UIs. Do you have other questions?
Now we have a working mic.
All right, we have a working mic. And I'm mostly just here to share what I'm super excited about and not tell you how to fix your user experiences. So.
How long do greyhounds live? No.
ask
The
your
real
dog.
question, it seems there's the gestures and then there's the voice. Is there any consideration for a hybrid approach?
So I think there's a lot of potential in-air gestures, especially if you, so think about being, the thing about voice is that you have to have very specific vocabulary, right? At this point, we have to have very predefined vocabulary. And that vocabulary, if you said, oh, show me a bunch of pictures of dogs, and then you were seeing this on a wall, let's say, a wall display. So show me pictures of dogs, and a bunch of pictures of dogs popped up. How would you tell it to go, and how would you tell it to show you more pictures from that same set? Would you say, scroll left, go up, show me some more pictures? What phrase are you going to use? Show me more? Okay. And then how would you go back to the other, like go back? Would that take you back to your earlier state, back to the previous dogs? Wait, that dog. So that's the place where, in that selection, or thinking about interacting with a wall of dog pictures, is where gesture can be helpful because it can say, okay, I'm going to swipe across. I want to see more dog pictures. Rather than you, and this is this another paradox is the mental model one where we are trying to think about how a computer is thinking about things. And it's a really bad trap to be stuck in. So they're like, oh wait, what does the computer want to hear? But then the person, ideally, we are not saying like, oh, how is the person going to think about how a computer thinks about this thing? That's horrible. You don't want to get stuck in this loop. And so the nice thing about gesture is instead of thinking like, okay, how is the person going to talk to it about the third result from the bottom, is the person can point to that and say, that one right there. That's the one I want. And so those are the places where they can start to be combined. But I think that works best on when you consider a wall-based interface or a TV-based interface. It's not so great when you're thinking about on your phone. And it's still really awkward to switch between the two on a small device. Does that help you at all? Or you can design some stuff for walls? Okay, so I think that's what I'm excited about with that meshing of those two is in these larger interfaces. Yeah.
So everybody knows greyhounds do live to be about 14 years old, depending.
All right. 14
So
years old.
I'm going to take the prerogative of the microphone for a second.
Okay.
And Abby, as you know, before I did UX and UI, I did sign language. So are we learning lessons from people who use gesture every day for their cognitive load and incorporating that into what us impoverished gesture users might be able to learn?
I don't know. I have to admit, I haven't looked into sign language and how that works.
I would be happy to point you at all
Sounds
the
good.
relevant research and the big conferences, like 200 people. It's great.
Cool. See, when there is this, so the International Society for Gesture Studies, they don't study specifically iPad gestures and swiping and zooming. They're studying how gestures help us communicate better when we're talking to people, or how, well, mostly about communication. So they're really thinking about, as I stand up here, you know, as I say, oh, the wall of pictures. That's the kind of gesture they're considering. And those are the kind of gestures that are really important to consider as you're designing something as well. If the gestures that you work on don't have actual meaning and don't have concrete things that they refer back to, they're going to be really hard for people to remember. Do we have questions, I think? Or Kira?
Hi, Abi. I have done some experiments on gestures and I found that people love it, but when you actually put them in front of a gestural system, they get very intimidated. And do you think that, and I've seen that that happens between genders too, the reaction. And do you think that if tactile feedback was included along with audio and video, visual feedback, that they would feel less intimidated and more natural?
So
And
the-
I don't know how tactile feedback can be done.
Yeah, so the tactile feedback is a huge problem with just about any touch interface we have right now, is that we don't get any return when we swipe it, except for the potential, like whatever you ate for lunch, pulling on your finger as you swipe across on an iPad, that kind of thing. But drawing on an iPad is really difficult because you don't get the same feedback that you do from drawing on paper. Thinking about using a voice-based device, on Google Now, no matter how quietly I say, okay, Google Now, it's like beep. And I'm just like, no, be quiet. It doesn't adapt in any way to what I need. And so I think it's something similar with wall-based systems. So as you play around them, the feedback that you get from them is not always equivalent or appropriate to the response that you've given it. So if I approach something like Connect and I press like this, and it's a gentle press, should I get really glaring feedback back from it, or should I get feedback that's responsive to the way that I interacted with the device? And I think that's something that we have the capability to do, but we're not necessarily doing right now. The other thing is, I have to say, most of the time I use the voice interfaces, I'm by myself. I'm in my car. You know, it's just like singing in your car. That's how using voice interface is for me. Or it's something I happily will do on my own, but as soon as I'm around other people, it's a lot more difficult. And there's the same awkwardness of testing these things in a lab. It's really hard to get at the actual use. But at the same time, you can't really just install a wall-based gesture system in somebody's house, can you?
Working my way around.
So I wonder if you could speak to how international gestures are. Like if, I'm Italian, so I can say it, but if Italian gestures or Swedish gestures or Chinese gestures might be different, or Japanese.
That's why I ordered the book, Field Guide to Gestures. It talks about gestures around the world, and I'm not sure they still have it available on Amazon Marketplace, but I got it really cheap. It was like $3. And it's great because it tells you about gestures all over the world, including a new one I learned is where you pull down your eye like this, and it can mean a few different things. It can mean, are you paying attention? It can mean yeah, I see what you're talking about. Or it can mean, like, check out that really hot person over there. Which is funny, because one could be in a work context, like, hey, do you see what I'm talking about right now? And the other one would be like, whoa, check out that person. What's that? Oh, it's a field guide to gestures. And so what these people have done is they've just figured out these gestures that folks use all over the world. It has a lot of pictures too, and it describes the gestures. And it's sort of fun to go around making gestures and trying not to offend your colleagues with new ones that you've learned. And there are offensive ones in there as well. But it can be a help. But at the same time, we were talking about at dinner, trying to make products that work for everyone all the time can be really difficult. So on Google Now, we have internationalization. We don't just have English, but we have different modes of English, because my colleague who's British, Google Now has no idea what he's saying unless he sets it to British English. And so as we think about gestural systems, it'd be really nice to be able to do the same thing. Right.
So the concept of different layers of interaction is really interesting and important. I spent a lot of time thinking about it in the context of voice, and trying to think, how would you design voice systems that handle interactions at multiple of those layers simultaneously? And I know that, you know, on Connect and on the mobile voice assistants that you mentioned, the solution is not to handle different layers simultaneously. Basically, you've got one layer active at a time. Either you can talk to the entire system, or you can talk to an app.
Mm-hmm.
And I'm wondering what your thoughts are on sort of moving forward. Are there ways that we might be able to address that?
So I think on the Connect, though, it's possible to talk to the system while you're talking to the application, right? Like, you can accidentally switch out of playing a game and lose your entire game because you switched to TV by accident.
Oh, actually, yes, you're right.
So you
on
can-
Xbox One it is. On the original Connect,
sorry, yeah.
it wasn't. But
So on Xbox
you're
One,
right.
you can be playing a game, and then somebody can hit the gate words for switching to TV, and then you're just totally screwed.
Yep.
You can watch people have videos online where their roommate comes in and is like, watch NBA jams, and they're just like, no. So you can do that to people. What's tough on there is that it makes you say the entire name of the television show that you want to watch, which, if it's a really long name, is horrible, especially for live events. They often have very long names. So it'd be like the 22nd Olympiad, you know? So you can't just be like, I want to watch the Olympics. Like, you have to say the exact name of the program. So yeah, that happens all the time on the Xbox. There's a conflict there. In some ways, I'm fortunate. I work at a company where we make an operating system, but at the same time, I don't work on the operating system team. So the interactions that I get to design for happen at the content level. They don't even happen at the application level, because at the application level is a browser team. So you have the Android team, then you have whoever's making the browser, and then eventually you have the things that I'm working on. And so I always have to understand and know what are the different ways that people can interact with these other tools and watch out for them. Because in the end, the further down you get that stack, those are the things that are probably going to win. I don't want to put it in combat terms, but I think they own the system, you know? And that's the reason why we always end up pulling down notifications when we just wanted to refresh an app, is because the lower the level you get there, that's probably going to win in the end.
Yeah, and I think the challenge has always been, if you're the operating system developer, if you're the system developer, you want to enable developers to use these capabilities, but then how do you do that and also allow for these system-wide things like swiping down from the top and switching TV?
So on Xbox, it's like 2 and 3 word phrases. That's it. That's all you get. They have very specific ones and a limited number of them. But who has all of them memorized, I guess, is the question. And so it's going to be at that point where you feel like you can actually talk to your computer or your Xbox and not just try to remember the specific phrases or commands that it knows. And once we get out of that command mentality, I think once we have interfaces that let us get out of that command mentality, That's when we'll start to see some different ways of interacting with all of those different layers. But I think as long as it's just based on essentially the phone tree model, we're going to have a lot of trouble.
I tend to be very hesitant to experiment with gestures because a few too many times something happened, I don't know what I did, I don't know where I got here, and I don't know how to get back. How much of that is just my cautious personality, and how much of that is a human factors characteristic?
It is not wrong to be very cautious about that. Gestures largely lack an undo. So in Google Now, you swipe away a card, and then at the very bottom, it's like, hey, you swiped it away. Do you want to tap this thing? And you only have 2 seconds to tap it, and then it's gone. And it's not very friendly, and it's not very easy to use that. So I think especially considering the need for manual dexterity that you have to have when you're interacting with gestures, it can make it really difficult and make you feel like you need to be really cautious with them. And it's true. There's no Control-Z for a gesture, the way there is for a keyboard shortcut. So I think it's a valid concern, and I don't have a way to solve it right now. Aside from showing, we call a toast. Show a toast. Do you want to undo the last thing you did? But do you really want to see undo every time you delete something? Probably not.
Hey, Abby, I'm wondering if you have any thoughts on potential for overuse injuries for voice or gestural interfaces?
Well, the one with the arm issue was really interesting. I don't know, have you guys ever felt like after you use a touchpad a lot, your fingers are almost sore or tired, your wrist? So they're just those general things. I mean, I remember when I first got a touchpad laptop, I wore off my fingertip from being on the internet too much, which is really frightening. So there's a lot of potential for injury. I think though, significant amount of potential for injury in gesture-based interfaces really comes from dancing games. So that's probably the one to really watch out for. Yeah. All right, a couple more questions.
Hi, and thanks for the talk. It's very interesting. I was wondering for the gestural interface, for example, some solution is very specific to one use case, like the swiping for like volume up and down. And how does we design gesture that across all the domains? Because I think for volume adjustment or like an air fan, thinking in car, the air fan. Strong or weak adjustment is kind of the similar that you can kind of for the same gesture. But if it gets too more complex, like if you need to navigate to a certain place, or if you need to make a phone call to a certain person on the contact list, how does the same gesture cross all the domains?
Well, I think if we're thinking about gestures in a car, so right now, I think one of the nice things about gestures is you could have direct manipulation as well. It would make things considerably more expensive in a car to have direct manipulation of fans. And what I mean by that is to put the gesture for increasing heating or cooling on the vent itself. So moving your finger up along the vent to increase the fan speed or down lower. If you moved all those interactions out of the console, it's going to become very expensive in a vehicle, right? To have every single thing in a vehicle have those interactions. But if you start thinking about the proliferation of sensors and how much cheaper sensors are getting, that's always a possibility as well. And then there's the idea of the adaptive interface, right? Where your car could notice you're getting hot and could turn up the fan a little bit. Which is a crazy thing. I mean, I know I'm like saying crazy Silicon Valley stuff where it's like, then the car just sees you're hot and the fan turns on. And then you could say to your car, no, I'm fine. Turn the fan down, please. But without seeing an interface, it's really hard to speak to specifics of it. No.
Let's make this the last one. Thanks,
All right.
Abby.
One last question.
Okay, I just wanted to add something to the person who asked the question before. about the fatigue.
Yeah,
So
injuries.
I did the experiment to compare fatigue between touch screens and in-air gesturing. And what I found was that the shoulder and the arm, the in-air gesturing was better, but for the wrist, the touch screen was more ergonomically friendly. So yeah, I just wanted to answer to that question.
Cool. Yeah, I think there's more and more work being done on the mechanics of the arm and just what's more difficult on people. Thank you so much, though.
And thank you, Abby.
Thanks, you guys.